Hi student, I am Pavitra. I am very much happy to see you at the Pavitra Chemistry. Before starting the class, let's review the key points from our last class. In the last class, I had covered the topics like matter, classification of matter. Next is the physical classification of matter. Depending upon the physical state, I convey you that matter can be classified into three types: solid, liquid, gas. Next, chemical classification. Chemical classification states that two types: pure substance. Next is the mixture. Pure substance again classified into two types. One is the element, another is the compound. Element classified into metal, non-metal, metalloids. Next, compound classified into two types. One is the organic compound, another is the inorganic compound. Again, mixture classified into two types. One is the homogeneous mixture, second is the heterogeneous mixture. I hope all of you will have downloaded the notes by visiting the website pavitrachemistry.in or pavitrachemistry.com or pavitrachemistry.org. Before start the class, I would like to see you how you will download the notes. At first, go to the Google search engine and you can write your pavitrachemistry.in. Then you go Pavitra Chemistry. This is my website. You can download the class notes here. Now go to the download. Now give your mail ID. Here I will give the mail ID of mine. Pavitra.mahapatra. Here you can give your number. Then submit here. Look at that. This is the syllabus and this is the web link. By clicking this link, you can able to download the syllabus. Next, this is the notes for class 1. This is the notes for class 2. Today is the class number 3 for basic concept. After finishing the class, I will share the link here, like a trial here. Suppose I want to go the class number 1 notes, then click here. This is the class number 1 notes, some basic concept of chemistry. Here you can go download or direct you can print. Now this is your download file. Like that you can also go another web link and you download all the notes. After downloading the notes, it is better bring a class notebook and note all the contents in your notebook. I will provide notes of every class. I will provide 3 to 4 class in a week up to completion of the syllabus. I would like to give a like to the YouTube video to motivate me and inspire me, and share the video to reach other students. Subscribe the video, subscribe the channel to support me, and click the notification bell to stay updated with the latest class. Let's move to the topic, today's class topic. Today I will discuss about the composition of matter. Matter is composed of small particles such as atom and molecule. Atom means your paramanu, molecule means anu. The at first I will discuss about the atom. The word atom is derived from Greek word atomos, which means indivisible. Indivisible means you cannot break, but today science speak that atom can be break into subatomic particles. The subatomic particles are electron, proton, and neutrons. Next, what is atom? Atom is the smallest particle of an element that can take part in the chemical reaction. It may or may not have independent existence. Remember 3 points. Point 1, the smallest particle of an element. Point 2, take part in the chemical reaction. Point 3, may or may not have independent existence. What is the meaning? You know that independent existence means in ODID say to nijaswa astitva. Next is the smallest particle of an element, you know very well. Elements means molecule. Next, take part in the chemical reaction. Let's explain about this point. Suppose I want to take a reaction. Suppose here I will take an example. 2H2 2H2 plus O2 gives a to water. That is your hydrogen. Sorry, that is your water. Here, the equation is written in the molecular form because molecule is stable. Some atoms are, remember one important point, chemical reactions are always written in the stable form, that means in molecular form. But actually, at first, the molecules are broken into atoms. Then the atoms undergoes chemical reactions. That means hydrogen first gives a to hydrogen atom, oxygen gives a to oxygen atom. Then the oxygen atom and hydrogen atom react with each other to form the water molecules. That means atom are the smallest particle of an element, and it can take part in the chemical reaction, and it may or may not have independent existence. From this, we can concluded that there are two types of atom. One is some have a independent existence and some do not have independent existence. The atom like helium, neon, argon, these atoms have independent existence. But if you think about hydrogen, nitrogen, oxygen, they do not have independent existence. How can you know that which atom having independent existence and which atom does not have independent existence? You can follow the octet rule, and one is the octet rule, another is the uh, that is duplet rule. Octet rule means there are 8 electron in the valency cell. Duplet rule means 2 electron in the valency cell. Look at that. Here helium having 2 electron in the valency cell. Similarly, if you think about neon having also 8 electron in the valency cell. This is the valency cell, L cell. Next, argon having also 8 electron in the valency cell. Valency cell is your M cell. I will explain about the cell, subcell, orbital in the structure of atom chapter, unit 2. That is sorry, unit 3. That is your unit 3. Belongs to unit 3. Next, that means we can say that the atom which obey octet rule and duplet rule that are said to be more stable. So here we can give the examples of more stable atoms, that is your helium, neon, argon, uh, krypton, xenon. These are the examples of inert gas elements, and they are more stable, and these atoms are said to be the examples of atoms which having independent existence. Sorry, I will explain the structure of atom in the unit 2. Next, move to the. That means finally we can conclude that an atom is defined as the smallest particle of an element that can take part in the chemical reaction and may or may not have independent existence. There are two types of atom we consider: atoms having independent existence. One is helium, neon, argon. These are the example. Next, move to the atoms having having no independent existence. That is your hydrogen, nitrogen, oxygen atoms. Here, the valency cell do not contain the eight electrons or two electrons. That's why they are said to be unstable. That means they wants to stable by the help of another. You can't write hydrogen in a single hydrogen atom. It is always present in the molecular form. That is your said to be H2. You can write here H2. You cannot write only H, but you can write He because He is stable. It can present in a single atom, but hydrogen atom cannot be stable because its valency cell does not follow the octet or duality rule. So here hydrogen always exist, so their existence by in the form of hydrogen molecule H2. Similarly, you can think about the nitrogen molecule. Next is the oxygen molecules. They have um, uh, that means such type of atom do not have independent existence. Such type of atoms are generally considered as the atom having no independent existence. Clear? Next, I will move to the another point. Already I told you that atom is made by three subatomic particles. That is your electron, proton, neutron. Next, actually, the characteristics property of an element is generally expressed by atom, but not subatom. Let me explain this point. Suppose if I want to think about the characteristics property of an element, suppose I will take iron. Now, otherwise, take carbon. Carbon born itself. Listen, the characteristics property of carbon depends upon the atom carbon. There are different types of carbon molecules, that is your graphite, fullerene, diamond. These are the examples which are present in the molecular form. But the properties of these elements generally decided by the carbon atom, but it do not explained by the subatoms. Subatom means electron, proton, and neutron. Look, you know that carbon having different type of isotopes. That is your C16, C12, C16. Sorry, C6, 12. C6 13, C6 14. These are the isotopes of carbon. Here the number of electron, proton, and neutron are different. So you cannot say the properties, the characteristics of the carbon element depends upon the number of electron, proton, and neutron. It only explain by the help of the atoms. So here you can say that the characteristics property of an element is expressed by an atom but not a subatom. We know that the number of electron and proton are same in an atom, but you can say that the number of neutron is same with the number of electron and proton. But remember one important point: the charge of electron is negative, but the charge of proton is positive, but they having same value of magnitudes. That means here we can say that charge of electron is your 1 point. Here we can say that charge of electron is your how much? 1.6 1.602 into 10 to the power minus 19 coulomb. For proton you can write plus, and for electron you can write minus. Both having same magnitude of charge, but they are different in their sign. Negative is for electron, positive for proton. Remember here we know that the number of electron and number of proton in an atom is equal. So here we can say that the total positive charge is equal to the total negative charge. Total positive charge by total proton is equal to total negative charge by total electron, because the value is same, that is your 1.602 into 10 to the minus 19 coulomb. Again we know that neutron having no charge, it is a neutral species. Suppose I want to say that what is the charge of an atom, then you can say that the charge of an atom is 0, because we know that proton plus electron plus neutron, um, these three subatomic particles are responsible for the construction of an atom. Your charge of proton and neutron is cancelled with each other, that means 0. Your nitrogen is neutral, that means 0. So the total charge of an atom you can say that is your 0, that is your neutral. So here I can say that an atom is electrically neutral, because the number of electron is equal to the number of proton. Next, move to the molecules. Molecule is the smallest particle of compound that has independent existence. Remember here atom is the smallest particle of an element, so, but molecule is the smallest particle of a compound. Atom having do not having independent existence, but molecule have independent existence. Atom may or may not, atom can take part in the chemical reaction. Molecule do not take part in the chemical reaction. It first converted into the atom, then the atom will react with it, will take part in the chemical reaction. There are different types of molecule. Look at that here. Now we can present different types of molecules. Here helium, hydrogen, oxygen, chlorine, O3, ozone, sulfur. These are different examples of molecules. Look at that. If you think about the example, here helium having independent existence. That means it consider in atom list, also in the molecule list. You can think that there are a lot of helium atoms are present, but one helium atom is sufficient to stable. So here you can write He. Though it is not necessary to write He2. If you write He, then it can show that it is an atom or molecules. Depending upon the situation, you can consider that it is an atom or molecules. But here you can write He, not necessary to write He2. It is you can say that it is a molecule or atom depending upon the situation. Here, hydrogen is also a molecule, oxygen, also chlorine, O3 acid. If you think about these examples, all these molecules having same type of atom. You know that same means homo. That means all molecules are same. That means it is said to be homoatomic molecules. Next, if you will think about these molecules, look at that here. Different atoms are present. In case of water, two type of atom is present. One is your hydrogen, another is your oxygen. But the total number of atom is your three. Uh, Here we can say that different types of atoms are used for the formation of this molecule. Like that, you can think about the methane. Here, two type of atom is present, but the number of atom is your five. Similarly, you can think about ammonia. Next, you can think about glucose. These are the atoms which are made by different. Sorry, these are the molecules. These are the molecules which are made by different type of atoms. Different type of atom means hetero, so they are said to be heteroatomic molecules. That means here you can say that molecule is classified into two types. One is your homoatomic molecules, another is your heteroatomic molecules. Look at that. Again, the homoatomic molecule classified into different types depending upon the number of atoms. If the homoatomic molecule is made by one atom, then that is said to be monoatomic molecules. Look at that here. Helium is made by one atom, that is said to be monoatomic molecule. You can say that also argon, neon. These are the said to be homoatomic molecule, and it is also belongs to the monoatomic. That means homoatomic molecule. Here there are this is also belongs to here hydrogen also belongs to homatomic molecules. Here two atoms are present, so that is said to be diatomic molecules. Here oxygen is also said to be diatomic molecules. Chlorine is also said to be diatomic molecules. But if you think about the ozone, then ozone here look at that ozone having um, three atoms. So that means you can say that ozone is a triatomic molecules. Similarly, you can think about the sulfur atom. Here the sulfur molecule. Sorry, not sulfur atom. Here, if you will think about the sulfur molecule, here eight sulfur atom is present, so it is said to be octa atomic molecules. That means depending upon the number of atom, you can classify the homoatomic molecule into different types. That are monoatomic molecule, diatomic molecule, triatomic molecule, tetratomic molecule, like that. You can classify depending upon the number of atoms. Next, move the heteroatomic molecules. Look at that. Here, water is given. Here, the two type of atom is present. At first, it belongs to the heteroatomic molecule. But look at that. The number of atom is three, so it is said to be triatomic molecules. Um, Next, if you will think about the diatomic, similarly, you can think about the tetratomic molecules. You can think about the pentatomic molecules, hexatomic molecules. Look at that NaCl, CaO, HF, HCl, KF. These are said to be diatomic molecules. CaCl2, CF2, SiO2, CO2. These are said to be triatomic molecules. BF3, AlCl3, NH3, PH3, these are said to be tetra atomic molecules. CCl4, CH4, SiH4, these are said to be pentaatomic molecules. There are, because there are five number of total five number of atom. Don't think about the type of atom. Can I say a question? Is there is possibility of mono heteroatomic molecules? Can you say is possible or not? No, you can think about the possibility of mono heteroatomic molecules. Remember, hetero means different. Different means you can start from two. Then you can think about two or more. Two means at least two means that is just said to be diatomic. So you cannot say about the mono heteroatomic molecules. These are all about the molecules and different types of molecules. Again, I will recap. Molecule is the smallest particle of compound. Molecule made by same or different elements. Same elements means homo, different elements means hetero. Homo, these are the example of homo, these are the example of hetero. Next, I will move to the properties of matter. Properties means dharma. There are two types of property. You know that one is your bhautika dharma, another is your rasayan dharma. Bhautika dharma means physical property. Next is the rasayana dharma means chemical property. At first, I will explain about the physical property. Basic upon the change of composition. Remember this word, change of composition. If a matter undergoes change in composition during the reaction, then such type of property of the matter is said to be chemical property. If its composition does not changes, that is just said to be physical property. So here we can say that the property of matter in which a matter does not change composition are called physical property. On the other hand, you can say that the property of matter in which matter changes composition. The change may be alone itself, that means itself, or by reacting with the other substance to form new substance. If a matter undergoes chemical changes, that is belongs to chemical property, then it form a new substance which having different composition from the original substance. That is your one is your reactant, another is your product. Take example, hardness. You know that hardness drudhata in Odia it is said to be drudhata. This is a physical property. Next, you think about the rigidity. This is also belongs to the physical property. Rigidity means kothinata. Next is the melting point, galananka. Boiling point means spotananka. These are said to be physical property. There are some examples which shows both chemical property and physical property. It is an interesting question. And give an example which shows both chemical property and physical property. Burning of candles. If you think about burning of candles, the melting of wax. When a candle will burn, then what will happen? It's wax. It's a wicks. Wicks means solita. Sorry, its wicks will burn. Simultaneously, the candle will melt. That means wax will melt. So we can say that melting of wax is a physical property because there is no change in the composition of the wax. Next, but if you think about burning of wicks and wax, some wax also burn simultaneously. Some wax melt. Some portion of wax, some portion of the candle will burn, and some portion of the candle, that is your wax, will melt. The melting of wax is belongs to physical property, but burning of wicks and wax belongs to the chemical properties. Next, I will move to the chemical property. Chemical property most related to the changes of composition. Change may be either alone or by reacting with other substance. Take example. If you think about the decomposition of calcium carbonate, suppose think about the decomposition of calcium carbonate. Let me explain. Let me show the reaction. I have taken an example, that is your decomposition of calcium carbonate. When calcium carbonate undergoes decomposition, when giving heating, then it gives calcium oxide and carbon dioxide. This property of calcium carbonate is said to be chemical property, because here the composition of calcium carbonate is different from the two product, that is your calcium oxide and carbon dioxide. Here, calcium carbonate undergoes decomposition by itself, by alone. It do not need the need another species, another reactants or catalyst. It undergoes itself when you apply heat. So it is one type of chemical changes, and the property of the substance is said to be chemical property. But if you will think about another example, hydrogen react with the oxygen gives you water. This is the also chemical changes, and the properties belongs to the substance said to be chemical property. Here what happens, hydrogen needs the help of oxygen, and oxygen also needs the help of hydrogen to form the water. Such type of property are said to be what, that is said to be chemical properties. These are the example: decomposition of calcium carbonate, burning of magnesium in air. Burning of magnesium means you can write here Mg. You can write here Mg plus Mg plus O2 gives MgO. This is your burning of magnesium in air. That is also belongs to your chemical property. Next, I will move to other points. This is the general classification of property. One is the physical property, another is the chemical property. But property also can be classified into two types. One is the extensive property, another is your intensive property. This is the other way of classification of property. This can be clearly explained by the help of quantity of matter. Let me show an example. Suppose I will think about the volume of this water. Suppose if you think about the volume of this water present in the beaker, you can say that maybe it shows how much, 100 ml. Maybe suppose take it's suppose 100 ml. It have some also some weight. Suppose if you think about this, this cannot be said to be 100 ml. This is maybe suppose taken as 200 ml. If you think about the quantity of water, here the quantity of water is more, here the quantity of water is less. If you think about the volume, that means here volume depends upon the quantity of water. If you will take more water, more quantity of water, that its volume will be more. Here more water is present, more amount of water is present as compared to this beaker. So the water present in the mug having more volume. That means here volume depends upon the quantity of matter. Suppose if I want to say about the boiling point, think about the boiling point. Suppose I want to think about the boiling point. Boiling point of water is your how much? Boiling point of water is your 100 degree centigrade. Suppose I want to give heat to this water. Then after attaining the 100 degree, after attaining the 100 degree, the water will start boils. That means the boiling point of water is here. We can say that 100 degree centigrade. But if we think about the boiling point of this water, here also the boiling point of this water is here also 100 degree. But remember one thing: the amount of water present in the beaker is not same with the amount of water present in the mug, that is your jar. That means boiling point does not depends upon the amount of substance. Remember one important point: volume depend upon the amount of substance, quantity of the substance, but boiling point does not depends upon the quantity of the substance. What amount of water you will take, all waters having same boiling point. Similarly, you can think about the freezing point of water 0 degree. This water having 0 degree. This water having also 0 degree. That means the water present in the mug or present in the beaker both having same freezing point, that is your 0 degree centigrade. From this discussion, here we concluded that some properties are present which depends upon the quantity of matter, and some property do not depend upon the quantity of matter. What amount of substance is taken, that is does not matter. The property value remain constant. Here we can say that volume, another say melting point or boiling point. Here volume is said to be extensive property, but melting point, boiling point, depends upon the quantity of matter, so it is said to be intensive property. Like that, you can think about the density. Density does not depends upon the quantity of matter, because if will take more quantity of matter, mass will increase, simultaneously volume also increase. Density is equal to mass by volume, so the ratio of mass and volume, that is your called density, is remain constant. So density is here also an intensive property. Clear? Next I will move to the some special property. First is your hygroscopic in nature. Hygroscopicity. I will explain three terms. One is the hygroscopy, efflorescence, deliquescence. I will go through the example. Look at that. This is your quicklime. You know very well. When quicklime will keep in the outside, that means in the environment, what will happens after some hour or some few days, it is wetted. Wetted means what some water molecules will absorb by the quicklime. Some water molecule absorbed by the quicklime, and the quicklime react with the water molecules. It may form hydrate. You know what happen? It may form hydrate. It may form hydrate or hydroxide. You know that if you will keep the quicklime very more day, then it become the solids. That is just said to be hydrated quicklime. It contain the water molecule. As a result, it look like this. This property of quicklime, that means it automatically absorbs the water molecule from the atmosphere and converted into the hydrated or hydroxide form. Such type of substance is said to be hygroscopic substance, and the property shown by the substance is said to be hygroscopicity. Similarly, you can think about the other substance. You can think about the copper sulfate, that is your blue vitriol, anhydrous copper sulfate. Here you can say that copper sulfate showing the hygroscopic property, and say copper sulfate is said to be the hygroscopic compound. Look at this part. This is your the white part is your anhydrous copper sulfate. Then it will absorb the water molecule. Then it converted into the hydrated form. That is your blue vector. Hydrated form it in 5 water. So the formula you can write here CuSO4 5H2. That is your said to be blue vector. This is your only CuSO4, but this is your said to be CuSO4 5 water. Your CuSO4 absorb 5 water molecule and it converted into CuSO4 5H2O. When it absorb 5 water molecule, its color also changes. That is your blue. It looks like blue, so it is said to be blue vitriol. It is also said to be blue stone. Then you will subject it to demoisturize. That means you will provide heat to the copper sulfate. Then 5 water will vaporized and it converted into again anhydrous copper sulfate. Such type of compounds are generally said to be hygroscopic compound, and the property is said to be hygroscopic compound, hygroscopicity. Similarly, on the reverse, here you can say that this is your said to be blue vector. That means it contains 5H2O. If you will present in the atmosphere, then what will happen? Automatically, depending upon the atmospheric condition, it loses water molecules, and converted into the anhydrous copper sulfate. Depending upon the atmospheric condition, summer season it can possible, it can slowly possible, but 100% for 100% it needs more times. So some substance absorb water molecule from the atmosphere and convert it into hydrated and hydroxide. That property is called hygroscopicity, and the compound is your hygroscopic compound. Similarly, if you think about the efflorescence, this property is said to be efflorescence. Some substance are present which automatically loses water molecule and converted into the powder form. The substance is called efflorescent, and the property is said to be efflorescency. Next, another special property is here. You can say that this is also example of efflorescency. This is your hydrated gypsum, but if you think about the hydrated gypsum, after few days it loses the water molecule and converted into the powder form, and the color here, look at that, change will change. So these are the example of some efflorescent. Next, I will move to the deliquescency. There is a relationship between hygroscopic and deliquescency. In case of hydroscopy, what will happen? Substance absorb the water molecule from the atmosphere and react and convert it into hydrated or hydroxide form. But here remember, such type of substance absorb water molecule from the atmosphere, no doubt, but they absorb until they dissolve. That means they absorb such amount of water that as a result it will automatically form a solution. Look at that. This is your FeCl3. This is your anhydrous FeCl3 present in the solid state. That is your said to be anhydrous FeCl3. But if it will keep in the outside, then it automatically absorb the water molecule and it dissolve in that absorbed water molecule and form the solution. This is the only difference. They convert into hydrated hydroxide, but such type of solvent do not convert it into hydrated hydroxide. They make solution. These are the three important difference between hygroscopic substance, efflorescence, deliquescence. I will again conclude. The property by which a substance combined with the moisture of the atmosphere and is converted into hydroxide or hydrate is known as hygroscopicity, and the compound is known as hygroscopic compound. Example is your quicklime. You can think about anhydrous, Na2CO3, anhydrous copper sulfate, etc. Next, efflorescence. Efflorescence, in other sense, you can say that to pour out. The property by which a crystalline hydrate. Crystalline means spatica. You know that solid having two form. One is your amorphous, another is your crystalline. Crystalline substances are generally showing such type of property. The property by which a crystalline hydrate molecule loses. That means it must have a water molecule in the structural form in their structure. They help to build the structure of the crystal. So here we can say that the property by which a crystalline hydrate molecule loses water and form a powdery deposited on the crystal is called efflorescence, and the compound is called efflorescent. Example is your blue vectoral blue stone, that is your copper sulfate, CSO4 5H2O, gypsum CSO4 2H2O. They having water initially from the beginning. They have water, so they loses the water molecule. After losing the water molecule, the crystalline is converted into the amorphous. That means they form in the powder form. They present in the powder form. Next is the Na2SO4 10H2O, cover salt. Next, we move to the deliquescency, the property by which a substance combined with the moisture of the atmosphere until it is dissolved in the absorbed water and form a solution. It's called deliquescency, and the compound is said to be deliquescent. Anhydrous APCl3, NOH, KOH, KOH, NOH. It shows more deliquescency property. When you will keep the KOH NOH in the outside, then it automatically form the KOH solution, aqueous solution of KOH. Similarly, aqueous solution of NOH is formed from a NaOH. Next, I will move to the malleability. Malleability is the property of a metal to be hammered into a sheet. If you will apply force to a substance, and it may be converted into a plate like this, then the property of the substance is said to be malleability. Next, if you will convert the substance into wire, when you will stretch the substance, then it converted into wire. That is your said to be ductility. Here you can define the property of a metal to be hammered into a sheet is known as malleability. Example: copper, silver, gold, showing malleability character. The most malleable substance is your gold. That's why you can able to form different types of ornament with minimum amount of gold. 10 gram of gold, you can make a diamond, make different types of ornaments. Next, ductility. The property of metal to be drawn into wire is known as ductility. Example is your copper, silver, gold, aluminum, etc. Platinum is the most ductile metal. If you take 1 gram of platinum, then it can be drawn into a wire about 500 km. Similarly, if you take 1 gram of gold, it drawn into a wire about 4 km. Next, very important point, one is the plasticity, another is the elasticity. Elasticity means clearly related to the elastic rubber. That means when you pull the rubber, when you apply some external stress to the rubber, suppose this is your rubber, if you will stretch the rubber, this is your take an example. I have take um, the nylon and polystyrene. Remember more important points. If you will stretch something, then it will increase their length after removing the force. It will regain its original shape, size, or volume. Then such type of sample are said to be such type of property of the substance is said to be elastic elasticity. If they do not regain its original shape, size, or volume after removal of the stress, that is your external force, that is said to be plasticity. We can say that when a solid substance cannot regain its original shape, size, or volume after removal of a certain limited stress, then the property of the metal is called plasticity. Example is nylon, polyester. Elasticity: when a substance regain its original shape, size, or volume after the removal of deforming force, then the property of metal is are called elasticity. Example is your steel, ivory, glass. Actually, it is very difficult to show the elasticity of the steel, ivory, and glass because by applying maximum stress, such type of substance shows the elasticity property. If you think about the plasticity, nylon, polyester, such type of substance showing the plasticity. Polythene, better example is your polythene. If you stress the polythene, then it does not regain its original shape and size. But if you stress the rubber, then it regain its original shape and size. Nylon cannot show the property like rubber. Polyester also doesn't show the property like rubber. So your nylon and polyester are said to be plastic substance, and the properties are said to be plasticity. On the other hand, steel, ivory, and glass, they are said to be elasticity. These are the some special properties of the matter. Again, I will recap. Composition of matter. Here you can see atom, molecules, homoatomic molecules, heteroatomic molecules. General classification of properties of matter are physical property, chemical property. You can classify again two type: extensive property, intensive property. Next, special property: hygroscopicity, efflorescence, deliquescence, malleability, ductility, plasticity. Next is your elasticity. Now, okay, for this class. Next class, I will discuss about the symbol and radical and its classification. Thanks you all for watching this class. Um, again I will repeat you. You can download the class note by visiting the website pavitrachemistry.in, pavitrachemistry.org, pavitrachemistry.com. At last, I would like to give a like to motivate me for next video. Share the video to reach near the other students. Subscribe to this YouTube channel to support me, and click the notification bell to stay updated with the latest classes. Think like proton. Stay positive with Pavitra Chemistry. Have a nice day.